Okay, this would be covering the part of the test that was over section 5.7. This is the hard part of the test for a lot of people. For a polynomial, I'm on question 10 by the way. For a polynomial function, if k is a 0, that means if k is a 0, it means f of k has an output of 0. Okay? What must be true about k if it is not x-intercept? So we usually think of zeros to mean where x equals 0 or on the x-axis. But we already learned that there are some numbers that you can get to complete these functions. There are some numbers that when you set it to 0, you can force it to solve. Those are called imaginary numbers, but they actually never cross. When you draw them, you never see them cross the x-axis. So the word 0 is kind of a trick in the sense that it really means when the function gives you an output of 0, which we usually assume is the y value, and that's true, but you can't, when you actually go to graph it, the x values are actually imaginary, and so they actually don't show up on the real number line. So the key is that if you get imaginary zeros, then the physical look of it, you cannot see them cross the x-axis. Okay, number 11. F is a polynomial of degree 9. So we'll say n is 9. That's an odd number. Odd functions must cross they look like this. They have some kind of look like this. And then they end up going up as well. In order for that to happen, they can cross more than once, but they have to cross at least once. So the minimum number of times is one time. If you have two different ends of tail and you have an x-axis, it has to cross at least once. Even if it only crosses once, it has to cross at least once, because the end behavior of an odd degree function is opposite directions. Part B, it's the same function, n equals 9, but they said, what is the maximum number of times f can be tangent? Well, you're going to tangent functions, when you're tangent, that means you must have a multiplicity that's even. So the lowest even number is 2. So that means you get zeros like, let's say it was x minus b to the 2 or 4 or 6 power. So we're going to use the lowest one because the lowest even number is 2, and that will give us the most tangent zeros there, tangents at 0 there. Now, there's another problem. Remember we just talked about if it's odd, it has to cross once. So if I'm going to cross once, that would have an odd to cross. That has to be an odd degree. And the lowest odd degree is 1. So if I go 9 minus 1 is 8. If I divide 8 by 2, that gives me 4. That is the maximum number of zeros that are tangent. Remember, we use the lowest even number. We had to cross once, so that gives us that there. And so that we needed to subtract 1 and then divide by 2. That's kind of a tricky one. Okay, so in questions 12 to 14, we're using this function here. And P and Q are real zeros. In other words, they're not imaginary. So we don't have to worry about pretending to cross, but they don't really cross. So they do somehow have to touch the x-axis. Okay, and remember, this x is really x to the first. So the first thing it says is how many zeros does it have? Well, let's check the powers. We've got a 1 plus we've got another 2 plus we have a 3 here. So that's 6. So for number 12, there's our answer for number 12. I should write it in black. There's our answer for the number 12. It's 6. Okay. Number 13, it asks us how many distinct zeros. Distinct zeros are zeros that you can actually count on the x-axis. Well, if we set this, the first x equal to 0, well, that's one distinct one. Then we had x minus p equal to 0. That means x equals p. That's one. But you say it's squared. Well, this one happens twice, but you only see it once. So it's one distinct 0. And then the other one is x minus q. Set it to 0. And you get x equals q. So there's a third time. But again, it only happens once, so it's distinct. So we have 1, 2, 3 distinct zeros. Okay. Okay, so in number 14, it says describe the behavior, whether it's tangent to the x-axis or does it cross the x-axis. And we have those zeros there. Now again, we're using this function here, so we're talking about these particular spots. And we already talked in the last one that we had these zeros when you set them to 0. And so they're showing up right here. Those are showing up right there. So on the first one here, on this one here, the multiplicity is 1. How do I know? Because it's x to the first power. So if it's an odd, which is odd, since it's odd, it's going to cross the x-axis. Even if it gets close to flat, it's going to cross it. Okay? It's not going to be that flat though. Okay, this one here is a 2, which is an even number. So it must be tangent. It's going to bounce off the x-axis. It's going to touch it, but it's going to bounce off of it. It's not going to go through it. Okay? And then the last one is a 3. 3 is an odd number, so it must cross as well. Now some of you said it flattened. That's fantastic. If it did, it gets a little bit flatter. The higher the degree, the flatter it gets. But it's only going to cross it once, but it's going to actually cross over it. Okay, that should end. Well, there's some more questions for section 5-7, but I'm going to continue on with another video.